And I want us to pay attention. Now, the very first question I want us to consider is this. I can't share the screen right now. Once I have the hosting rights, I'll share the screen.
You can share the screen.
Not now yet. I'm still not the host.
You can share it. I've enabled you to share.
All right. So you can see my screen now. If you cannot speak up, you can send a chat. I said that earlier. If you can't use the mic, you can send a chat. All right. So we are starting off like this now. The first question says, what defines strain? We are considering elastic property of a solid is a recurrent question in WAEC. So I want us to take time to look at it so that you can be well prepared for the exam. Now, define strain. Okay, now strain is one of the main properties of an elastic material. That one is stress. So what is strain? Now the strain is a comparison between the increase in length which an elastic material undergoes, okay, to the original length. Now, if you stretch the elastic material, for instance, and the increase in length is 50% of the original length, okay, that the strain that you achieve is less than when you have an increase in length of 100%. What this means is that the increase in length you achieve when you stretch material is what determines the strain on the material. So the higher the increase in length achieved when you stretch a material, like a rubber band now, you stretch it. All right. So the increase in length you achieve determines the strain that the material will experience. Now, so the actual definition they want you to say here is that it is defined as, there are two definitions. I want you to write them down. Number one, strain is the ratio of extension to original length. It is the ratio of extension to original length, or it is the increase in length, it is the extension per unit length. It is the extension per unit length. It is ratio of extension to original length, or it is extension per unit length. Extension per unit length. Now, look, the next question says, a rubber band is stretched to twice its original length. A rubber band is stretched to twice its original length. And they now ask us to calculate the strain. Now, first of all, the first thing is, what is the formula for when you want to make a calculation in physics? You need to know the formula first of all. So in this case now, the formula is extension E over original length. Now, the extension is the increase in length, or the new length. Sorry, the extension is the new length minus the original length. All right, the new length achieved minus the old length. The new length minus the old length over the old length. It's as simple as that. So now, in this question, the increase in length is what? Now, since the old length is, assuming the old length is L, and now the rubber band has been stretched to twice its original length. So what will be the new length? Because they said it is stretched to twice. So mathematically now, what will be the new length? Okay, if you can hear me, just send me the chat. If you know, if you have an idea of the answer, I want the class to be interactive. Send me the answer on the chat quickly. If the original length, if the old length is L, then I stretch to a new length, which is twice the old length. And if my old length is L, so what is my new length? Send me the response on the chat if you know the answer. If old length is L and new length is twice the old length, what is the new length? If you can use your mic, you can also speak. Okay, yeah, nobody's responding. So in the proper class, there should be interaction. No. Someone said 2, but that. Well done for responding. Abdul Fattah, he said 2. 2 is just a number. I said if you have the old length as L, and then you now stretch that material to twice the old length.
4L.
Again? 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 Can you repeat yourself?
4L.
Okay, well done for attempting. It is supposed to be 2L. They said twice. They said twice. Twice is supposed to be 2L. Okay? So for your contribution, but the new length is 2L. So now my next question is that since old length is L and new length is 2L, so what is the increment now? If you know the answer, just type it or tell me. Old length L, new length 2L. Increase in length is old length, is a new length minus old length. So what is the answer now?
Old length.
Okay, just do the math for me. Can you just do 2L minus L for me? Just do 2L minus L. What's the answer? 2L minus L. What's the answer to that? 2L minus L. Yes?
L.
Correct. So I believe those who are not responding are also maximizing this section. So 2L minus L is F, correct. Okay. 2L minus L is equal to L. So now the extension is equal to what? L. Now, if you go to the formula for strain is extension over original length or old length. So now my final answer will be what? L over L. So the strain in this question is L over L. So what's L over L mathematically? Who knows the answer? What is L over L?
1.
Correct. All right. So the answer to this question is 1. So the strain of this material is 1. So if you're preparing for WAEC now, don't ask 2 direct questions again. So I won't want to have you ignorant of what is obtainable right now. The season has changed. Questions are no longer based on knowledge, but based on understanding. Okay, so they are more of applied questions where you need to show that you properly understood what you were taught. Okay, now let's move on to the next question now. The next question, so the strain, the answer is 1 because it is L over L, and that is 1. Extension is L, original length is L. As you can see where it is solved there. All right, let's move to, if you have any questions, you can just let me know. Now, strain is just an aspect of elastic properties of a solid. At another time, we'll take another aspect of it. I'd like us to take them in bit. I want us to touch different areas. Okay. Okay, next question is about fiber optics. Now, fiber optics is now replacing copper cables because of certain advantages that it has over copper cables. Okay, so before I go to this question, I'd like to give you the advantages of optical fibers over copper cables. If you notice in your areas, you see people underlaying some excavating and underlaying some pipes. Those pipes are not water pipes, they are actually optical fibers. They are telecom companies trying to underlay optical fibers used in telecommunication. Okay, all these telecom companies that are the ones actually doing that. Okay, before I answer this question, I want to take down the advantages of optical fibers over copper cables. So write it down. Just write advantages of optical fibers. Advantages of optical fibers over copper cables. Advantages of optical fibers over copper cables. Number 1, optical fibers are cheaper. Optical fibers are cheaper. Number 2, optical fibers carry more data. Optical fiber carry more data, that is, they carry more information, because no communication is transfer of information. So optical fibers, number 2, optical fibers carry more information. Then number 3, optical fibers has greater bandwidth. Band, B-A-N-D, the width, W-I-D-T, D-T-H, bandwidth. Okay, so you can see these are the 3 main differences, main advantages of optical fibers over the conventional cable wires, copper cable. Okay, let's now look at, they're asking us what are the materials used for making. Before we also go to this question, I want to give you their uses. I want to give the use of optical fibers. Optical fiber uses. Number 1, I hope you are writing. I don't know if you are writing or. I don't know if you are writing or. Hello, are you there?
Yes, sir.
Fantastic. Okay, number 1, it is used in telecommunication. It is used in telecommunication. In telecommunication. Number 2, it is used in defense, military now. It is used in defense. That's the military, it is used in defense. Then in the industry, it is used as light guide. In the industry, it is used as light guide. Light guide. Used as light guide for lasers. Used as light guide for lasers. Used as light guide for lasers. As light guide for lasers. That's in the what's it called now? In the industry. Then in medicine, are you there now? In medicine, number 1 is used in endoscopy. Endoscopy is like you want to examine your throat. For instance, maybe someone has sore throat or someone has ulcer. That's what it's used for. It's used to achieve. It is used to achieve that. They also in medicine it's used it's used in surgery. Yes, it is used in it's used in surgery. That's yes, it's used in surgery. Also as light guide, also in surgery. It's also in medicine. Used in medicine for endoscopy and then in surgery. Because the light is very intense. The laser light is intense, and then the fiber optics will help to send the light to areas where ordinarily the human eyes cannot get to. Okay, these are some of the very important use of optical fibers. Okay, let's go to the question that we have. They say we should state the materials used for making optical fibers. Materials used for making optical fibers. Let's just list them. Let me just give you them. You don't need to list as many, just list only 4. Just pick only 4. Just so I remember only 4. Don't need to stress your head. Remember only 4. 4. Number 1, write sapphire. Number 1, sapphire. Number 1, sapphire. Sapphire is SAPPHIRE. Then we have glass. We have glass. We have Teflon. Then we have silica. We have silica and then we have silicon. They are different. Silica is an element, while silica is a compound. Silicon is an element, the silica is a compound. You can confirm that from your chemistry teacher. We have just 5 minutes to go. I think we cannot. Let's just use that 5 minutes to discuss. If you have any questions, just let me know. We have 5 minutes remaining. We cannot use that to. We can't go any further. I believe you've learned 1 or 2 things. So I think we can draw the class to a close here. Yes, we can end the class here. Hello, Sam Jason. Can I end the class here now?